Hello, in this video I will do indoor lighting. In the background you can see already a video that I did of indoor lighting. It was a few years ago and it was using the high definition render pipeline HDRP of Unity. So this is a pipeline that we use, a rendering that we use when we work on PC or console. But now what I want to do is to do a lighting for VR. Actually for the Quest 3, using it without PC. So it means that everything will be rendered directly on the processor of the headset. And for that, I need to use a URP rendering engine of Unity. This URP rendering engine is for a mobile device, so phone, tablet, and of course headset. So the difference between the two is of course the quality. And for example, in HDRP, you can have a lot of lights, many lights in real time with shadows. It's not something you can do with URP. URP, we will try to bake a maximum of things. And if we have lights, better to have only one, and actually the shadows are even not be soft, they will be hard shadows. So we need to do a few tricks to have something nice. But yeah, it's very different from HDRP. Okay, so let's go in Unity. So I use a VR template of Unity. So I work with Unity 6.3.9. This VR template is good, and I checked the parameter, and they are good to work with the Quest 3. Of course, there is just one thing I had to do in the build profile. By default, it was Windows, so I changed to Android. I could use MetaQuest, but I prefer to use Android in case if I want to export it for another headset. But what I put, I think it was already in the other parameter by default, but I just put texture compression to ASTC. This is what the Quest 3 need. Okay, I will not work with this scene, but what I will do, I will use the XR origin hand and the hand permission manager that we have in this scene. This is what allows you to move in VR, teleport, select an object, manipulate the object, click on the menu, etc., etc., with your controller and with your hands. So here I will right click on this prefab to know where is it, okay, and I will reuse it in my scene. And this one I check prefab. This is this one. So I will use this one and this one, okay? But first I create a new scene. I don't need the camera, okay? Because this XR origin has already a camera. And I use hands permission manager. So now we are ready to import the assets. So the assets are the same that what I used in the previous video. This is this attic that I downloaded online. So I will put the link in the description. So my model are here, if I'm correct. Yeah, so I will use this attic. So what I did, I removed a lot of objects. And here, if I check the stat, we are at, from this point of view, oops. Yeah, we are at more than 100,000 triangle, okay? Yeah, so I will just put it at the center. I will just double check where is this guy. So I will put it here. And permission, no need to do anything. So we have the attic. And now we have also the sun here, this light. What I will do, I will move it because when I'm in the room, I like to modify the sun without having to go up. So I will just put the sun in the middle of my room. Position of the sun has no effect on your lighting. Of course, only the direction has an effect. So I select it and I will turn it to have some light entering by these two windows, okay? So here, for example, I will have the shadow here, okay? Quality of shadow is not good yet, but we will work on that later. Now I just check the position. And there is something we can see already. There is what we call a light bleeding. So what is it? It's, of course, I have the light coming from the window, but if you watch well, you have also the light coming from the ceiling, between this floor and the wall. So that it happens very often, especially I think this geometry is just a plane. If it was a cube for the wall, you will have less the issue, but it will happen very often. So this light bleeding is it's like if two walls were not sealed well and the light can enter. Why it's like that on Unity, or it's the same on Unreal and not on Maya? Because they are real-time software. So they do sampling of the space to be very fast, render in real time, but the quality is not as good as pre-rendering lighting. So the solution, the simplest solution, is the old solution that before we were using on DCC software. This is to create planes. So for example, I will create here a quad. I will put it here, turn it. So you see the quad blocks the light, of course. So what I will do, I will put him where I have this light bleeding. So here you see if I put it behind the wall, it will stop the bleeding that I had. Okay, so it's as simple as that. And so I still have bleeding here. I will just scale it and no more bleeding. So here what he does, he just creates a shadow, okay, on the object. So you see here, he creates a shadow, and I will be sure, of course, that he don't create a shadow inside. I have to stop it at the limit of the window. So what I did, I already created object for the light bleeding. This is here, but the thing is this object, so I will put it at 0 also. They were created for another position of sun. So here I have to readjust all these planes. So you see it's different plane here that blocks the light. So it will take just 2 minutes. So here I will be sure I stop the light here, but I don't stop the light to go inside the room. So I will stop here. This one, oops, selected everything. This one, I will block it here just at the limit. This one, don't know if I did it already. Yeah, here. And we have a second window. So here, I move it here. This one is okay. This one is okay. And this one, I will also move it like that. Okay, so now if I go inside, I should not see any light bleeding. You see? So, no worries. So far, it's a bit ugly. It's very bright. But now what I will need to do is to bake the light. So here, my light is real time. All this calculation in real time, especially the shadow, the VR headset cannot do it. The FPS, it can do it, but your FPS will be extremely low. We really target with this scene the maximum of FPS 72. So here, this light, instead of real time, I will change to baked. So what it will do, it will pre-calculate all the lighting and save it in a texture called the Lightmap. Okay, so here I will go to lighting. If you don't have a lighting settings, just create a new one, click on new. And this is where we will bake the light. So again, you take your sun, you put baked, okay, to have everything baked. Now you go to lighting, and this is where you will generate the lighting. But the next thing you need to do is to say what object will be baked. So when there is a baking, what he will do, he will activate a global illumination. He will use your direct lighting from the sun, and he will add the indirect lighting, the global illumination. But you need to tell him what object will contribute and receive the global illumination. So with this scene, with everything is static, nothing will move. I will just select my attic, but also the light bleeding object, and I will change them to static, okay, and with the children also. So now what I will do, I will go back to lighting. My son is baking. The objects are contributing to the GI. So now I generate the lighting. So it will take a few minutes, a few seconds, it depends on your scene. So perhaps I will stop my recording and restart when the rendering is done. Okay, so it took 20 seconds, so it was very fast. But here we are with a default parameter. We can increase the quality and it will take a little bit more time. So what I see here is not perfect, clearly. So first thing, when I calculate global illumination, I will move here with this one to the baked light map. So it will show me what is a baked light map. So here I will just turn that off. And we see it's pretty good, but perhaps on the floor here it looks a bit messy. Here also it's super messy. Sometimes so that what it display here, it's the pure baking, okay? No texture, no shader, it's just the baking, just your lighting, okay? But actually sometimes you have this mess here, but when you go back to the classic rendering, you will not see it, especially if later you have the textures, okay? So the information of the texture will be bigger than this one, stronger, so we will not see. But here, okay, it's a bit dirty. So here you can adjust that when you check it. This thing is just for your preview. It will not affect the final lighting. Okay, so this one is always important to check your backlight map, because sometimes you will see very dark object, black object, very white object. If it happens, if everything is gray, nice, and in the center you have a pure black object, there is a problem. So problem on your geometry. Could be the UVs. UVs are not correct. So sometimes there is no UV. The UVs are not correct, especially you have overlapping. Or it could be a texel validity issue. So it means the normals, most of the time it's that the normal are not well oriented. Normally Unity will always calculate it well. Always check your geometry if your light map is not good. Here I can also show the light map resolution. So as I said, when you calculate the light map, this is a texture, and here this one allows you to check the resolution of the texture. For example, we can see that this bucket has less resolution than the floor, and it will affect the result of the baking. The floor will have better quality than the bucket. Okay, so always check with this one baked light map. So here my scene is a bit dark, but it's okay. So with VR, by the way, try not to use the post-processing because it's pretty heavy. If you can use zero post-processing, just do a nice lighting. So for example, here I will add perhaps more lights. Okay, so the rendering is interesting, but here you see when I move, some objects are very bright. It's not a light leaking. It's because we didn't create a reflection probe. So these objects, they are just a bit shiny and they don't reflect their environment, they reflect the sky. Because by default, there is zero reflection of geometries in Unity. Okay, so we need to create the reflection probe that will allow you to have real reflection. So I will right-click Light Reflection Probe. And here I will display the gizmo. I have this ball. This ball is a point of view where all the reflection will be calculated from this point of view. So I will put it in the center of the room. And here, this box, it's the distance of the reflection calculation. So only the object in this box will be reflected. Okay? So now the box is correct. I will select this reflection probe and I will bake it. And now you see it calculates all the reflection. And now in my room, I don't have this weird effect that I had before. Okay, so this part is brighter because the sun touched the floor and bounced on the wall. So once again, it's not very clean yet, but it's better. What else? So now that we have no more light light bleeding, and we have the reflection probe, we should refine a bit the lighting. So you go in lighting, you can see here you have the baked light map. So this is all the light maps that he created. So you can take an object like this one. He will show you this is here, and if I double click, this is his light map that he shared with other objects, and here I will see the lighting. Okay, and you see that this object is very small. So this texture is a 1K texture. It's right on here. And this object use perhaps very small proportion of this 1K texture. So he used perhaps only 50 pixels to calculate the shadow, the lighting. So it's not a lot. So what you can do, you can decide to increase the quality of this light map resolution. So what you will do, you go to light map resolution here and you put 80, and everything will be multiplied by 2. The problem is the light map size is 1K. This is this thing, 1K. It will probably be too small. So here I will put 2K. Sometimes I even put 4K if an object needs more pixel. Yeah, what I can do also, it's indoor, so the maximum of bounces of the light, we should put something more like 8. And here, light map parameter, I will also put high quality, high resolution. Then I will calculate again. So here we can, why not do a snapshot? You see this shadow quality is really not good. So I will do a snapshot and we will compare with a new resolution. Okay, so I keep this snapshot here. And I will generate the lighting again. So it will take a bit more time. So done, it took him 3 minutes and 30 seconds, I think. So now it's better. We will compare with what we had before. So you see the difference, okay? So that it was with 40 of resolution in the light map, and this one is 80, so twice resolution, so better quality. But actually, so it's on everything. It increases the resolution on everything. The thing is, it will take more space, of course. You have backlight map. Now we have 1, 2, 3, 4, 5 backlight map, but of 2K. It's okay, not a problem for VR. But imagine that, so this resolution will be good. Because later, if we have texture, nobody will see that this is a poor resolution here, okay? We just see it because there is no texture yet. But just in case, if for some object, the shadow is not good, messy, or the backlight map is messy, what you can do for specific object, you select the object, like here, this carpet, okay? And we will check first what is the resolution of this carpet. So here, it's 2K texture. It takes perhaps 1/10 of the texture, so it means it has 200 pixels. If you think it's not big enough, you select the object and you will change scale in Lightmap. So if I put 2, only this object will have twice of resolution. So when I will render again, it will be much better. Okay, so I will calculate it to show you and stop, of course, pause my recording. Okay, so he finished the rendering and I will show you the difference. Okay, so here it was with a parameter of 1, and here it's when I increased the resolution of the light map of this specific object. So again, it's when I change this value to 2. But you have to be careful because now you see this object has twice of resolution, but not this one. So now we can see the difference. So when you use it, be careful that between two objects or two pieces of wall, the resolution of the shadow is the same, okay? So that's all for this video. So this one, I tested it with this number of polygons. In the headset, everything was fine. Oh yes, there is just something. If you want to make this shadow a bit more blurred, it's different that the HDRP. So when you work with the mode baked, you have baked shadow angle. So that you can increase it. Of course, you don't see the result in real time. I will not recalculate it. But when you increase this value, it will blur a little bit the shadow. So actually, perhaps it will be good to use perhaps a value like 1 just to blur just a little bit. Okay, so when it's ready to send to the headset, so be careful. If I have the headset connected with a link and I click on play, I will see it, of course, on the headset. But this is a computer who will calculate everything, okay? So you must test it directly on the headset. Let the headset render to see the quality, because it will be different. The aliasing will be different. The shadows will be different. So, no, not the shadow, sorry, because we baked it. So, but here, if I go to build profile, what you can do to test it on your headset, if it's connected, so mine is not connected now, you go to Android and you, when your headset is connected, you click on build and run. So it will build the APK. It will ask you to save it on your computer. But every time you click it, when it's finished, it will copy it on your headset. Then you go to your headset and you play it. And you will really see the result from the headset using the processor of the headset. Then you can check the FPS. Because if you use just the link with play, the FPS will be good. If you use the APK, it will not be so good. So for that, I advise you to install this tool in your Quest. This is OVR metric tool. So you launch it first and you will have this parameter. So you will enable what you want to display. And later, it will always display this information. You can go in any app, the information will be here. So here, usually, I just ask him to show me basic information here. And, sorry, I clicked all the time. I will always see the value of my FPS, okay? So I can really check all the time if my FPS is okay. So it's how you will work. Now you want to put more texture, you do it, build and run, you check with the headset and you check if the FPS is not too low. Okay, so that's all. So if you have any question, you can contact me. or send a question directly in the comment of this video. Thank you.